Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z. Today's topics include a post on comparing Semgrep and CodeQL, some filter bypasses, and a cool SSRF exploit using UNIX sockets. As always, the solution for the spot the vuln will be covered on tomorrow's episode, and if you want to give that a crack, head over to our Discord, and there's a new thread created for it in the Spot the Vuln channel, kind of a follow-up one to last week's, so yeah, go ahead and check that out if you haven't already. And other than that, we'll get into our first topic here, which is a post by Doyansec on comparing Semgrep and CodeQL for static analysis. And I thought this would be a bit of a cool post to cover because we've talked about static analysis a good bit before on the podcast, mostly CodeQL though, not so much on the Semgrep side of things. And along those lines, I will state up front, I basically have no experience with Semgrep. The bit of static analysis I've done in the past has been with CodeQL. And so it was kind of cool to see an evaluation that they were doing between the two of them. Z, I know you have a bit of experience with Semgrep, so you maybe appreciated this post a little bit more than I could, or could take more away from it, I guess.
Yeah, I have used Semgrep a bit. Obviously, the past couple years, I've been a lot heavier onto CodeQL. Because, I mean, Semgrep is, in a lot of ways, grep, but more tailored to code analysis. So, you know, it's the name itself, semantic grep. Grep was huge when I was doing code review. As a consultant, I would often just grep for things. Then once I learned about Semgrep for things, or create some rules there. You know, it's kind of like building regex, tossing them on top of each other, making rules out of it. It's kind of what Semgrep does. Plus, it understands kind of the semantics of the code it's actually searching. So both of them kind of work in that area of analyzing code, but they're also very different tools, and I think have very different places. Although GitHub is trying to push CodeQL as being like part of your standard build process, it doesn't feel like it really shines there. I would actively, on a personal level, recommend Semgrep in a lot of cases over CodeQL. That's it. As this analysis, I did feel like it was lacking in some ways. So they included a lot of information, but it also felt like it was kind of biased one towards Semgrep in terms of how they scored certain areas. And I felt like it wasn't super clear on what the goal context use was. Because they talk about some of the places where, you know, CodeQL versus Semgrep, and Semgrep is better in like a CI environment where you want speed. They talk about some of those aspects in terms of like, you know, that runtime, the actual time to perform a scan, you know, takes whatever. Like it's a lot quicker with Semgrep to get up and started versus building with CodeQL because of how they work. And they mention things like that, but then they don't mention like other use cases of CodeQL. You know, CodeQL, I often talk about that as like augmented researcher in the loop sort of situation where, you know, I'm working on a large code base and then I want to query for data flow between something or look for how something's getting used. And that's where I might write up a CodeQL query. And they don't really talk about that at all, but then they try and make this seem balanced, so they're comparing all these different options. So it felt kind of lacking in that sense in terms of actually showing where CodeQL shines. One of the things that stood out to me is they're talking about doing this analysis for a client, but they don't, and maybe they just can't talk about what the client does or how the client wants to use these. But they end up talking about like, where's the option in here? One of the things they test here was this lexer parser functionality. And they kind of, now, first of all, in language and all like language support, framework support, Semgrep easily, you know, has more support for different languages. Plus it also, you know, will scan things like, you know, Docker file, things that don't make sense to do. Like CodeQL doesn't scan a Docker file. It doesn't work on text. It works on code. But one of the things that really stood out to me is they're talking the lexer parser functionality, and one, they talk about a lot of errors. I haven't had a lot of build errors. I have had builds that have failed with CodeQL. My personal experience has been very different from what they've had with a lot of these extraction errors. In my case, actually, I kind of got screwed over because So the way CodeQL works, if you're unfamiliar, is you have to build the database first, and then you can query it however you want. So you have the build stage, and then queries just run on that. And in that build stage, I had one case where I built the program. You just basically give CodeQL your build command, and it'll watch your build and figure everything out from there. See what files are used, how they relate. Did the build, had no errors come up during it, but the build had nothing. It couldn't follow the actual build because it was using a wrong version of Clang. Gave me no warnings about it, and that's definitely an issue. But so I finished that build, and just like, wow, my queries are giving me nothing. And kind of bit me there as I had to go figure out what was wrong, and that took a little while to debug, but I haven't had the case that they're talking about, so we have had very different experiences with CodeQL. But they end up kind of balancing this towards, well, Semgrep runs on incomplete projects where you just have a single code file. And I felt like that was a really weird kind of focus to give. And they do call out that it's not a completely fair comparison because Semgrep and CodeQL are different. But I don't know, I just kind of am left like, how many clients would they have that can't build their own code that they want to scan? Like, it's totally a benefit for like bug bounty hunters. People here listening, Semgrep might be more immediately useful than CodeQL. CodeQL, I imagine, more on like a long-term, very focused and in-depth, large code base and project. Like if you're looking in on Chrome or Linux kernel or something, but web apps, something like that, you pull out a random JavaScript file, Semgrep easily takes the win there. It just felt like a really weird focus at times that they had. That said, they also have had clearly a very different experience than I did. So, I mean, I can't fault them. They go through a lot of things here pretty systematically, and they pull out a lot of good details here, just between the two. Ultimately, they come down to, well, or they also run the comparison against OWASP benchmark applications and known vulnerabilities, and they just look, true positive, false positives. The results were very weird to me there too. They have CodeQL came out at 30% as their score, whereas Semgrep 42, just running with their basic built-in rules. And I will say CodeQL is also lacking on the default rules gain. I see it as kind of researcher working with it, not being used as like a CI tool to just catch everything. But CodeQL got like 0% on this weak randomness, which is really weird to me because the queries that Semgrep has for it look in this case, it's looking for Java util random usage. Literally the same thing CodeQL does. So I don't know why it got 0, but it screams like something else was going wrong here too. On a whole, though, like if you are wondering about the two tools, I actually will mention also that Semgrep themselves have kind of a comparison with I think, well, this is the page. This is the page that they linked for it. I think it might be somewhere. Yeah, comparing Semgrep to CodeQL. They have a little bit of comparison as to kind of how they work in the very high level thing here. That's also worth checking out. I mean, it talks a lot about the benefits of Semgrep in this post. I feel like they kind of let CodeQL down a bit with this one, but obviously they use Semgrep for themselves. They have more experience there. I have more experience on CodeQL, so that's going to bias both of our perspectives on it.
Yeah, I mean, on the analysis of broken code or incomplete code, the way I read that is like they're auditing their client's code base, but maybe they don't have access to all the dependencies for some reason. So that might be why they couldn't feed it through CodeQL properly and build a database, but maybe they could do it on the file scope level.
Oh yeah, and
that's
that
just
happens.
maybe like my interpretation of it. But
that happens all the time, but they were doing this comparison of Semgrep versus CodeQL. It sounded like they were doing this specifically to compare those two options for their client to use. For their clients' use. So that's why I kind of called it. I was like, I can't imagine a lot of clients are going to be not able to build their own code. But of course, in the consulting side on bug bounty, it totally happens. So it is It's where, like, if you're looking for a scanner, Semgrep easily wins, I think. Semgrep has way more rules. It's been around longer. It's more mature. And, well, I guess CodeQL did exist as, like, the private thing. CodeQL is kind of new in the sense of being available for use, but for a lot of reasons, Semgrep is better. Also, just Semgrep, you're allowed to use it on closed source. CodeQL is a lot more tightly restricted.
Yeah, that
Either
is
way.
one limitation we didn't mention when we were talking about the differences between the two, and it is pretty significant. CodeQL is more of like a commercial thing where it's like it's free to use on open source projects and whatnot, but it's not free for companies to use. Whereas Semgrep, it's free. They do have a premium option, but the licensing is quite different there too, which is going to skew its use case.
Yeah, like you can CodeQL explicitly, you cannot integrate it into your CI unless you're on like GitHub Enterprise or whatever the level is for CodeQL stuff. Where Semgrep you can. They have extra kind of unlocked features if you go with either like the hosted stuff, whatever their more premium offerings are. But Semgrep on a whole is just way more usable.
Yeah.
But
Um,
on a personal level, if you're looking for something to be in the CI, Semgrep wins. Like it's fast, it works, it catches those sorts of somewhat surface level issues, whereas CodeQL lets a researcher, somebody who understands the code base, kind of dig into it. Because I mean, it is comparing like a grep like tool. Semgrep is being kind of grep like with like an entire database system. Like the power of it's you're doing different things, querying something versus scanning for something. Like it is hard to do this comparison. They have done something here. They have compared them. I don't feel like everything was fair. That's just me, and I think by now people kind of understand I'm a bit of a CodeQL fanboy. I'm very big on using CodeQL, so that could just be me. But on the whole, like there's a lot of good information in this post, though. Like
yeah,
I
that's the
don't
way I
want to
look at it
say
too.
I don't want to say it's a terrible post. Or like don't read this, it's crap or something because they don't come to the same opinion as me. There's just another use case I don't think is really being compared here. Perhaps because that's what the client demanded, but I didn't feel it was clear enough on restricting the use cases.
Yeah, so I mean, even though these are both static analysis tools, they have different use cases, and it's almost like an apples to oranges comparison, even though they are the same like genre of tooling. So yeah, it's interesting, and obviously for their use case, they found Semgrep was better for what they're doing, which is totally fair. And so the post is biased towards that, but there is also like I did appreciate some of the comparisons here, especially as someone who isn't super familiar with Semgrep. Seeing kind of where it's targeted and where it shines was cool to see, and gave me a little bit of information there. So it is still a useful post, I think, and has some cool information there if you were looking at doing some SaaS tooling and needed some information on that. But yeah, just be aware, like what Z said. Um, for like their particular use case, it does seem like Semgrep was just the more suitable tool, basically. It kind of comes back to that thing of like use the tool for the job, and for what they were doing, that was Semgrep, because it operates on the file level and it's more for scanning as opposed to CodeQL for running queries and trying to do more of that code flow analysis.
And in fairness, I will say, and I think CodeQL is kind of mistaken for pushing this route, but I guess just me. But CodeQL does try and push itself now onto that. Like run us in your CI. I mean, that is something that GitHub goes and offers is running CodeQL queries or integrating very nicely as part of the CI. Um, so they do that and they do push that. It does feel like the wrong place for CodeQL to me, but there's definitely more of a market for that than for kind of our security research focus. So I mean, it makes sense why they're pushing it there, and they don't compete with Semgraph that well, in my opinion. Um, but yeah, I mean, I've said my piece.
All right. So up next, starting off some exploits, we have a post by James Sanders on a deep dive into a Node.js package called GOT, which is an HTTP request library, which he ended up looking into as he was looking at MediaWiki security updates and noticed a mention for GOT, which they use as a dependency. And again, this seems to be one of those issues where the underlying software does a little bit too much. It tries to support a sensitive feature and doesn't do it properly. So, for a bit of background, back in 2015 in GOT 4.1.1, they added support for making requests through UNIX domain sockets. For those not familiar with what those are, they're basically used for like internal IPC and communicating between different internal services and such. It's a
It's
pretty heavily concept in Linux.
it's kind of like opening a localhost socket, except you'll use a file. And so you have kind of the same power of just writing arbitrary data over a socket, but you've also got all the file permissions of a file instead of just a remote socket. So you have a lot of that. So it is faster, it is more performant, it is heavily used in a lot of web stuff to pass or run an application on a Unix socket and just expose that file through like Docker or something, as a way of passing things around. Anyway, go ahead.
Yeah. But it is like a pretty sensitive thing to expose, and it's generally not something you want exposed over the internet. But yeah, got ended up adding support for that, and they added support for the Unix and HTTP Unix scheme. Though, funnily enough, the direct Unix scheme didn't end up working due to a different bug, but they don't really go into that. The core issue here, though, is just the fact that GOT would follow redirects automatically to Unix socket locations. So if you, as an attacker, can provide a URL to an application using GOT, which it'll follow, and the attacker can provide a URL that redirects to a Unix socket, which could be very useful to exploit for abusing an SSRF, because there's a lot of potential attack vectors you can do with that, such as communicating with a Docker socket if there's one present, which you could use to like export containers, create them, execute commands, getting logs, things like that. Some pretty sensitive things you could end up leaking or exploiting. But yeah, like it's not just Docker sockets. There could be some other sockets running too, depending on the setup.
Yeah,
You
your
Go
ability
ahead.
to abuse this will depend entirely upon what's running on the server. This is almost feels a little bit more like a research post in the sense of, or at least part of the reason I wanted to cover this one was because I thought that was a cool idea. I don't think I've ever really tested for just making a request to a Unix socket. I'm not even sure that thought has really crossed my mind in the case where you've got something with an HTTP request. It kind of makes sense, especially some applications will effectively expose HTTP over the Unix socket, um, to run like a management interface or something of that style. So it's completely valid, at least a test, and that's kind of why I want to have this topic covered, because it just felt like the sort of thing that, it's worth just tossing in a test for it. Is it going to work most of the time? Probably not, and hopefully not. But at the same time, it's an easy test to run, and it has happened here. And it would be a pretty interesting finding to have that redirect going to a Unix socket.
He also states here that in GOT, redirects are followed for basically all redirect codes. So by using a temporary or permanent redirect code, 307 and 308, you can also get a post request through without having to rewrite to a get request. It seems the deprecated request framework was also vulnerable to the same sort of issue. But as I said, it's deprecated. It seems to be like kind of abandoned. So, that's just kind of called out there, but it's not super surprising. In the case of MediaWiki specifically, which kicked this research off, it didn't turn out to be too big of an issue. It seems they were only using GOT as part of their test suite. But some of the modules they updated also rely on that request library that's been deprecated. So kind of comes full circle. Maybe it is more impactful on MediaWiki because of the dependencies use of the request library. But yeah, at least directly in GOT, it wasn't a problem for MediaWiki. But yeah, like you said, a bit more of a research post. This could be something that impacts other projects too. But it's going to be really dependent on the target setup and getting a URL through in the first place. So
Yeah,
yeah,
it depends on basically having an SSRF already, and this is a way of um, actually exploiting it. If maybe it's somewhere like you can't access metadata or you can't access uh if it's not port scan it, it's not running anything. It's another thing to consider. Like I said, it's an interesting test case that I expect won't work very often. I'm hoping a lot of things don't follow redirects around or make just when it's expecting to do HTTP, send that right off to the Unix socket. But I'm also not surprised by that. 'Cause like I said, some Unix sockets will just expose effectively HTTP over that. So I'm not surprised by it. It's just something that I would immediately just start tossing in on tests. Is it going to work? Probably not, but it's worth tossing an easy test for.
All right, so up next we have a post by SecConsult which talks about DNS, particularly closed DNS resolvers and some of the attacks that can be performed there. So towards the beginning of the post, they talk about what closed resolvers are and what they can be used for. Um, Basically, the idea that it's not open to the internet, or it's not supposed to be. It could be used for like hosting service providers, company clients, stuff like that. But yeah, the idea is they run on an intranet. They're not supposed to be like publicly accessible or easy to hit publicly.
Yeah,
Um,
oftentimes like they'll have IPs or domains that shouldn't resolve externally. Like, a random shop might be using .local within their own intranets. And their internal DNS resolver will actually resolve these internal domains or be used for that sort of thing. Um,
yeah.
yeah.
So the article then goes into some detail on some cases where that isn't particularly true, with not being accessible to the internet, especially when it comes to things like password reset and anything that has to do with email functionality. Which for password reset, they have a previous blog post that touches on that. But that assumed there was like a web application exposed and it had something like a password reset or newsletter functionality. This post is talking more about the email side of things and looking at spam filter stuff. So things like SPF, DKIM, and DMARC for email authentication, queries that are involved for that. So yeah, they look at the spam protection, where the email server will send DNS queries for those records to an authoritative name server. So they experimented with like what happens if we send an email to a server with our own attacker name server um, that does analysis basically. So yeah, by specifying their own domain for their email, they can get the closed resolver to send queries to their own setup ADNS to analyze the name resolution, which allows them to both read and manipulate traffic going to and from their ADNS. Um, they use that to probe for security features. Primarily, they focus on the source port randomization, which is fairly important because it's the basis for preventing things like the off-path attacks, which Kaminsky used for cache poisoning DNS resolvers. Figure 6 does kind of a good job of showing what they're talking about there. Um, so yeah, they started going through some domains, sending emails, seeing what they could find in terms of what servers might not have source port randomization. Um, the results were mostly disappointing until they got to this one domain. And I just pulled up the scatter plot on the screen here. This one domain they looked at, they mapped the source ports, and you can see that does not look very random generally.
Not
Those
much
are
of a
those are pretty
scatter
static.
plot.
Yeah, it's more of a line chart. Yeah, so they ended up finding this domain which had a basically a static distribution of source ports, and it turned out after further analysis of the resolver's IP, they found via the ASN that it belonged to a hosting provider, and it was also associated with an ADNS. So they were able to find hundreds of domains that were hosted, um, that were communicating with that ADNS, which they sent emails to do further analysis. They then found hundreds more domains that were using static source ports. Not only that, they were able to find hundreds more via the external email provider that was also linked to the resolver. So yeah, it seems they were able to find kind of this network of IPs or servers that were, or sorry, resolvers that were vulnerable to static source ports. From there, they talk about some of the stuff you can do with this and some things you can attack, such as things like email spoofing by getting manipulated responses cached for the DKIM and DMARC records. But yeah, I mean, the main idea here is just the idea of challenging that the idea of closed resolvers not really being closed, at least not entirely. That's the whole basis for the blog post. And yeah, I thought it was kind of cool, using emails in this way to attack closed DNS resolvers. But after that, it mostly goes into like some of the stuff that's already been known about. Um, the core novelty is just that idea of using emails to hit close DNS resolvers.
That's the novelty, although I do think it is worth kind of talking like briefly here about what that old Kaminsky style attack was. In terms of why does not randomizing the source port for a request. So um as DNS resolver is going to make a request out, it's going to use or it should be using some random port to make that request to the other server, and then it replies to that port. DNS happening over UDP means there isn't a proper connection established, so it's going to open this port and it's going to wait and listen for basically anything to come back to that port. So by using a random port, he'd have to go through all the possible ports. But you can kind of race this. It doesn't have any, well, depending on the security mechanisms in place, it doesn't have any security tech to prevent just a random attacker from sending a response before the actual server replies. And in that race, you're able to give it the wrong result to whatever lookup it's trying to make. So that's kind of the core attack. Is then you can even just spam that port with a bunch of responses. You need to know what what domain to try and look up, because that's part of the response. But you can just spam requests there and basically hijack or poison its internal cache for what the IP for Gmail is, or what the IP for any MX mail server record is. It's a cool attack. It is something that feels like it could have also been forgotten about as an attack. Pretty old. It's like this was first for over like 2008, so fairly old sort of attack there, but something that I feel like hasn't been talked about, or it's easily forgotten as even a threat. And yes, the internal resolver is more likely to have less security updates, be seen as just that internal service, so not exposed, not as much of a threat. And this is just as a post showing here's a way we can still kind of attack those, probe them, find things out. There is a little bit of a stronger security sense than there was in 2008 in terms of preventing this. Like, there will be a bit of effectively a nonce or a token inside there that you'd have to predict depending on the security features, but internal services are also less likely to use those. So yeah, I felt it was worth at least talking about what that original attack was, because they're showing that it's still valid, in 2022 now.
Yeah. Towards the end, they state that they did the responsible disclosure process. They contacted the affected ISPs and hosting providers that they found. But yeah, obviously they say, we cannot scan and fix the whole internet. So there are likely other DNS resolvers that are vulnerable to this. So again, this kind of falls into that research category where you can take away this attack and maybe find it on some of the other targets that are out there. Perhaps even something that you would be auditing. So yeah, something to keep a lookout for and just keep in your mind, I guess, is to try something like this.
Yeah, and just in general, good posts, good coverage of it. They're talking about an attack and a new way of looking for it, but also of covering the Kaminsky style attacks here.
Yeah. So up next, we have an NCC group advisory on a bug in the OpenJDK's InetAddress get all by name method for resolving host and IP strings to addresses. And as you can probably guess, it's a parsing bug. And the parsing here is quite complicated because this method can take a host name, an IPv4 address, or an IPv6 address. In which case, if you provided an address, it'll validate it. Now, obviously, IPv4 and IPv6 have pretty different formats. IPv4 has the dot notation with each octet separated by dot. IPv6 IPv6 has the hex strings with the routing prefix, subnet, and interface. Importantly, though, in IPv6 you can also specify zone and interface IDs, which is denoted by a %. Honestly, personally, I absolutely hate looking at IPv6 addresses. I just scan over them because they're so annoying to read. But there was obviously a requirement for a more complex format there. But in things like this, it makes the parsing pretty difficult. So yeah, the bug here gets into when it comes to parsing that zone interface ID, which this get all by name method will pass along to check numeric zone for doing that. The problem is check numeric zone assumes that a closing square bracket represents the end of an address string. So if it sees like a closing square bracket, it will break out of the loop of parsing the zone digits. The problem is it doesn't actually verify that that closing square bracket is the end of the string. It only verifies that it doesn't appear directly after the percent. Additionally, get all by name doesn't validate that the extra square brackets are not present. Like it will check that it begins and ends with the square brackets, which get removed, but it doesn't check for any extraneous ones. So an attacker could end up bypassing validation due to get all by name calling this zone function that doesn't properly check um, for the presence of square brackets, and it'll just stop validating when it receives one. So you can kind of smuggle unchecked input behind the square bracket, basically.
Yeah,
A bit.
we'll kind of mention there that feels a little bit like the check numeric zone is just doing its singular job. It knows that it's taking, it's got the percent there, it's checking percent, followed by a value, then the end of that string. And it doesn't really seem to care about the validation at all. In fact, it almost feels a little bit like the validation aspect of get by name, get all by name. The fact that it validates IPv4 addresses as being well formatted just feels like one of those extra little features that maybe it doesn't even need to have. And so, whoever wrote the vulnerable check numeric zone here is just unaware that that's even a point of it and that it needs to do that. It just feels like the sort of thing that somebody else decided that this thing also validates it versus just parsing an address out of a string. So this one does that versus somebody else saying that's supposed to validate. And so it just gets entirely missed. At least that's how it feels like this could have been introduced.
Yeah, it's a bit of a strange one. Because yeah, they strip those square brackets further up, but then they still allow them to get through, which is ultimately what causes this bug. I think the fix for this actually just made it so the square brackets don't make it that far, and so they don't break out of the loop and check for the closing square bracket because it's not supposed to be there in the first place. So yeah, kind of an interesting bug in that respect. But yeah, the idea is just that you can smuggle the unchecked input behind that square bracket. They have some examples here that they show that I have up on the screen. And yeah, the recommended fix was to just modify check numeric zone to not even check for the square brackets, or to just re-implement the entire interface to be more strict. But that was a bit of a big ask, so I don't think that's the route that they ended up going. But yeah, fairly low impact issue here. As they say towards the top, this kind of input validation isn't really appropriate to protect against like injection attacks. And so it's mostly like a low risk issue, just something people maybe could use, but it seems like it'd be more of an annoyance than anything. But yeah, I mean, my main takeaway from this post is IPv6 parsing is hard,
Yeah,
which
and
I already
I
knew, but
I entirely agree with saying like that it feels weird that this would even be used as a validation. Like I was surprised that get by name could also be used as a validator, so I don't imagine it's being heavily used as like a validator. They use some sample code here where they're building a process to call ping, and they get the host and they run the host through get by name to validate the host as like a valid address. And then they just toss it right in there. Like, just don't do this step and it wouldn't matter. Feels like, you might be able to get something out of it in terms of like SSRF. Again, the sort of thing it's worth just being aware of. It's an easy test case to toss in there. That's probably not going to work in a lot of cases. But you can toss it on, your word lists or whatever and see what comes up. It did happen once. It might happen again. But yeah, it feels to me like using get by name as the validation is going to be exceedingly rare.
yeah, it's pretty weak as far as validation goes.
But a fun bug nonetheless. I mean, token parsers always seem to have bugs of some sort. Often we end up having token parsers with more memory corruption bugs, but the higher level use for one of those bugs, I guess.
Yeah. All right, so our last post is a post by Tantosec on an RCE in the DOM PDF PHP library for rendering PDF files, which was fixed in 2.0.1. And it's a bit of a follow-up vuln to an RCE we covered on episode 129. So I'll let Z get into this one.
Yeah, back on episode 129, we covered a really cool DOM PDF issue where they had an XSS on this website that like did nothing. It had no sensitive data. There were no requests they could make, no login, really nothing they could do with this XSS. Like you could export pages as PDF, and so their XSS would impact the PDF renderer on the server, and they ended up finding a way to get code execution from there by remote font. So if you had like a CSS font face and you enter the source of the font, and it will download that remote font face as, if it was a .php, it would just download it as a .php, and then they could execute code assuming the server was set up to do so. To fix that, what they did was they enforced that no, it's not going to download a .php, it's going to download a true type file, TTF, and it's going to make sure that it's a valid true type font file. So they kind of enforce that as the fix there. And so this bug is kind of going to build off of that as kind of one of the constraints. And then it also builds off of another bug that I don't believe we covered, which was that anywhere that source was used, like the source attributes, so like in CSS, you can set source for like an image or background image, you might source URL, give it something like that or whatever, would support Phar, Phar, PHP archive. You can give it a PHP archive file, and while normal HTML cannot understand that, since this is DOM PDF and PHP on the server, it would understand what a PHP archive was and read it, and you get code execution that way as it deserializes whatever's in the PHP archive. So that bug was fixed, and I believe they have it an example of some of the patch here. Yeah, right here. Where what they did to fix that was they basically looked at the protocol, and they introduced a allow list, block listing sort of system where you can dynamically allow certain protocols or disallow them. So, they'll fetch the get allowed protocols, check for the array key of whatever they parsed as the protocol, issue a warning if it's not in there, and then return. Problem is that, well, that is usually how they did it. I think they're looking at like CSS. Yeah, load CSS file here. That's how they patch in load CSS file. But in register font, which is the same place where the bug we covered on episode 129 started from, they patched it here, and maybe you can already spot the vulnerability, but it's missing one very important thing. It's missing the return after it issues the error. So
This is a
it's
really
checking
damn
the rules.
Bug.
I have no idea
this
how.
happens.
I know, because like you think of the copy and paste sort of errors. This wouldn't happen with that. If you copy and paste it, you would have the returns. Those returns were explicitly removed. It makes me feel like this was an intentional backdoor. Because basically this just doesn't check the allowed protocol, so they can still get a Phar file through. Yeah, I mean, it feels intentional to me. It really does, because why aren't they tracking the results somehow? I guess they do have, this, fancy PHP thing here for getting kind of the result and just result not equals true, but where they're checking the result, they're not doing the return. I don't know. I mean, it is very suspicious to me. The fact that it doesn't have those returns.
It kind of feels similar to some of the security checks we've seen in the past, mostly on the binary podcast, where in C you'll see like an assert or a debug assert that's being used for a security sensitive check. But because that assert isn't compiled into production builds, it's effectively not there. But in this case, you can't even like excuse it with macro magic or whatever. It's just straight up not there. So
yeah,
it's definitely weird.
If someone just wrote this on their own, and there wasn't the other instance of the code that clearly one of them was copied and pasted, it would feel okay, because it's like, okay, maybe they thought record warnings would also like end the run. It wouldn't return, sort of like treating it like that sort of function. But they do have returns elsewhere. that's kind of what makes it seem really suspicious to me, is the fact that they explicitly would have had to copy this and remove those returns from it in order to do that. So like the thought was, I'm not returning, and that was intentional. Um, yeah, I mean, we have no proof of that. It's just so weird to see it. Like I don't have a charitable interpretation of that.
It's either a really dumb bug or a backdoor.
Yeah, I mean, I usually try and have a charitable interpretation on these bugs. I have nothing for this one. I mean, so maybe in the commit logs the other code was first, and they copied it into this one and added the returns. And then why didn't they add them elsewhere, like on the other one? I didn't go look at the commits. So maybe I've got it backwards, but then it's kind of like, why did they add them in one place and not the other where they copied it from? So yeah, I mean, that's weird. Anyway, to kind of keep going with the actual vulnerability, this means that even though they check for the protocol and all of that, they don't care. You can just keep running, and if you pass it in that PHP archive, it would just execute it. It would keep going and run, just issue the warning, but keep going. And so they kind of combine the faults there. They have, so kind of recapping a bit there, if they could somehow write a true type file that would also be a polyglot as a PHP archive, then they can get a file written and executed here or they could use that first one to get a file written and then basically pass through as a PHP archive. And yeah, code execution from that. Which is basically what they did. They ended up going into talking about. So first, I guess I should also mention how they got the file right. Effectively, just comes down to using a data URI as the font face source rather than using a remote file, which is what we saw in the in episode 129 when we covered it. They just used a remote file that would get downloaded. They would use a data file this time too, like base64 encoded a string that would get written as the cache font face to be used. So that way they even avoided the checks for any sort of remote file downloading because data isn't remote. So they bypass that, get a file written as a polyglot, as a Phar, and then they can pass the Phar in to get that deserialized. And if there are any gadgets that can be used with PHP, I think they use PHP GGC, sorry. Gadget of that exactly what gadgets you're going to use for the deserialization. It's going to depend on the application and use and what type classes you have available. Kind of a different topic, but yeah, they were able to create that polyglot file. Mostly because PHP archives can have anything preceding them, much like a PHP file. It kind of just has a marker that indicates where it starts. So they could have all the true font or true type font information kind of stored at the head to create a polyglot. So it wasn't too difficult to have a polyglot file here. But it's still kind of an interesting chain, and nice to see a bit of a follow-up, bit of a saga out of this DOM PDF.
Yeah. But yeah, the main interesting part was just how the hell that bug gets through. It's a pretty insane bug as far as it goes. I did enjoy the way they exploited it though. Using a polyglot file like that is, it's always fun when you see something. Yeah, exactly. All right. Other than that though, that's all the topics that we have for today. So thank you everyone who tuned in. You can catch the VOD on Twitch immediately or on other platforms like YouTube tomorrow. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. If you want to join our Discord and follow us on Twitter, links for those are down below or in the chat. Once again, you can go ahead and check the Spot the Vuln channel in there for the solution or for the challenge that will have a solution on tomorrow's episode. Got myself twisted up there, but yeah. So yeah, like I said, we'll be back tomorrow for the binary episode. That'll be at 7 p.m. Eastern, 4 p.m. Pacific, which is where that Spot the Vuln solution will be covered. And yeah, we'll see you tomorrow.